Okay, then let me start. In the previous class, we have discussed about function. Okay, are you remember it? Domain, codomain, range. These are already discussed. Okay, and function is what? Function is a special type of relation in which all elements of the first set are associated with a unique element of the second set. Suppose we are define a function, suppose f from a to b, where a and b are what? A and b are two non-empty sets. Then f is said to be a function if all elements of the first set are associated with a unique element of the second set. Okay, so today I will discuss some specific type of function. Okay, I think all of you are understand the domain, range, codomain of function, isn't it? Hello, 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 hello.
Yes, ma'am.
Have you understand the function, domain of a function, range, and codomain of a function? Have you understand that the topic? It has already discussed. Okay. May I repeat it or not? Hello? Hello?
Yes, ma'am.
Tell me. May I repeat it not?
No need to repeat, ma'am.
Okay, then thanks. Then see this one. First, to first go through identity function, constant function. You have to know about real valued function. Okay, we have discussed about function. In that case, we consider two non-empty sets. Suppose f is a function from a to b, where a and b are two non-empty sets. Okay, suppose we consider that non-empty set is R. Okay, A is suppose R. R means what? Set of real number. Suppose f is a function from R to R. R to R, where R is what? R is the set of real number. And see that if we define a function like as from R to R, then domain of that function is what? R. Domain of that function is R. That is a set of real number. And the codomain is R. Okay, and here see that range of this function, this type of function is what? Is a range of this function is a subset of R. Okay, because when we discuss about function, we have already said that the domain is what? Domain is always the first set. Okay, and second set is what? Second set is considered as the codomain, and range is what? Range is a subset of codomain. So if we define a function from R to R, then domain of that function is what? Set of real number, and range of this function is what? Is a subset of real number, and that type of function is called real valued function. Okay, if we define a function from R to R, where R is set of real number, then we say that it is a real valued function. Okay, it is real valued function. So we are going to discuss about real valued function, specific type of real valued function. Okay, first the first one is identity function. In case of identity functions, see here, f is a function from R to R, which is defined y equals to f of x equals to x for all x belongs to R. Okay, for all x belongs to R, and in this case, it is called identity function. Here, see that f of x equals to x. Suppose we consider x equals to 1. Okay, then y equals to what? Suppose we consider for the identity function, if we consider x equals to 1, then f of x will be what? Can you tell me? If suppose it's very easy, see that we just write f x equals to 1. If we write x equals to 1, then f of x means y will be what?
One.
It will be 1. Okay, and similarly, suppose take y equals to, sorry, x equals to 2, then it will be what? Y is also 2. Okay, and suppose we consider x equals to, suppose, minus 2, then it will be what? It will be f of x will be what? Minus 2. Okay, for that type of function is called identity function. For all x belongs to R, f of x equals to x. F of x is what? It is nothing else, it is y. Okay, y means what? It comes from the elements comes from the second set. X is what? X comes from the first set. So we consider as x means what? It is the element of domain. Okay, and x belongs to R means what? It is the domain of that function. So x comes from the domain set, and y comes from the codomain set. Okay, suppose here we write as y equals to f of x. Okay, for the identity function, definition is what? Y equals to x, or you can say that f of x equals to x. And here see that domain of this function is what? Domain of this function is R, and range of f is also what? R. Okay, because range of f means what? It is also R, because we consider f of x equals to x. Okay, and next one is constant function. Constant function is also a real valued function. It is defined as f of x equals to c. C is any constant. Okay, any constant. Suppose we consider f is a function from R to R. Suppose we consider x equals to 1. X equals to 1. Then f of x is what? In that case, f of x will be what? We define that function like as f of x equals to c. C is any constant. Okay, and suppose we consider x equals to 1, then f of x will be what?
C.
C. It is c. Okay, so you can consider c is any number because c is constant. Suppose we consider, suppose c equals to 3. Okay, then for all x belongs to R, f of x will be what? 3. Okay, so for this type of function, domain will be what? Domain is R, and range is what? Range is C. The singleton set C. C may be any constant. Maybe suppose 3, 5, okay, minus 3, it can be root 2 also, okay, any number, any real number, okay, it's depend on you. Choosing of that number is depends on you. Okay, so constant function is also a what? Constant function is also a Real valued function, this is defined as f of x equals to c. C is any constant, and for this function, see that domain is R and range is what? The singleton set C. Okay. Next one is polynomial function. Okay. A real valued function f from R to R is defined as, you see that y equals to a naught plus a1 x plus a n x power n. Here see that it's very important. See that x power 1, x power 2, x power 3 up to x power n. These n are natural number. Okay, it's very important. Remember that this n, a1 x plus a2 x square plus a3 x square plus a n x power n. These n are natural number, and but the a not a1, these are what? These are coefficient. These coefficients are real number. Okay, these coefficients are real number, but the x1 x power 1 x square plus x cube, okay, the x power n, these are natural number. Okay, this type of function is called polynomial function. Okay, see that here also domain of this function is what? Domain of this polynomial function is what? The function is defined as f from R to R. So tell me domain of this function is what? Domain of the polynomial function is what? Jijumoni, tell me.
R में
Yeah, tell me.
R.
Yeah, it is R. Correct. Because always remember that if we define a function from R to R, then domain is always R. Okay, first set is always considered as the domain of the function. Okay. And here see that I have already told that a naught a1, these are real numbers. And now tell me, suppose I write as the function like as suppose x plus thrice x squared plus 4x cube. Is it a polynomial function or not? X plus thrice x squared plus 4x cube. Is it a polynomial function?
Yes, ma'am.
Yes, ma'am.
Yeah, tell me.
Yes, ma'am.
Suppose consider that x plus thrice x squared plus 4x cube. Is it a polynomial function?
Yes, ma'am.
Yeah, it is a polynomial function because here coefficients are also natural real number, and the power is what? Power is also natural number. And now tell me, suppose we consider an expression like as x plus root 2 x cube plus 5 x power 4, x plus root 2 x square plus 5 x power 3. Is it a polynomial function or not? Yeah, Samyukta, tell me.
No.
Suppose we consider x plus root 2 x square plus 5 x cube. Samyukta, go ahead. Tell me, it may be wrong.
Yes, ma'am.
Yeah, it is also a polynomial function because coefficients are real number. Okay, reason is what? Coefficients are real number. But if we consider like suppose x plus 5x power root 2. Suppose x plus 5x power root 2. Is it a polynomial function?
No, ma'am.
Yeah, it is not a polynomial function because the power is what? Power must be natural number. But here I say that the expression is what? X plus 5 x power root 2. Root 2 is not a natural number. It is a real number. So it is not a polynomial function. Okay. And next, see that rational function. Rational function is what? It is also a real valued function. It is of the type f of x divided by g of x. F of x divided by g of x. Here, one condition is very necessary. See that g of x does not equals to 0. Okay, g of x does not equals to 0. If we consider, suppose g of x equals to 0, then what happen? If we consider, suppose gx equals to 0, then can you define that type of function? F of x divided by 0. Can you define?
No, ma'am.
Yeah, we cannot define because this function does not exist. Okay. So the condition is that g of x does not equals to 0. Okay. And f of x, g of x, both are what? Both are polynomial. Okay, both are polynomial function. Here also domain of this function is what? Is R. Okay, because it is a real valued function, so domain will be what? Domain will be R, and range will be depend on the type of function. Okay, and next one is modulus function. Modulus function. Modulus function. Remember this definition because it comes in limit part also. When we discuss about limit, there are some problems related with modulus function. So try to remember the definition of modulus function. Okay, and see that modulus function is also a real valued function. So domain of this function is also R, and this function is defined look like as this type. Suppose f of x equals to positive. It is positive when x greater equals to 0, and negative minus x when x less than 0. When x is what? X is negative, then their functional value will be what? Minus x. And when x greater equals to 0, then it will be positive. So domain of this function is also R, and range. Range is always the positive real number. Okay, range is always, because suppose if we write modulus of -1, modulus of -1 value will be what? Mod of -1 is what? Mod of -1 will be what? Can you tell me the value? Mod of -1. Hello? 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 Mod of -1 will be what? It is also 1. Similarly, mod of -5, all are 1. If we take modulus of a negative number, then it will be positive. Okay, so modulus value of any number, positive, negative will be what? Positive. So range of that function is what? Positive real number containing 0. Because if we modulus of 0 will be what? 0. Okay, and next one is signum function. signum function is defined as f of x equals to 1 when x greater than 0. When x is positive, the value will be 1, and when x is 0, it will be 0. When x is negative, then value will be what? Minus 1. So domain of this function is what? R, and range of this function is what? 1, 0 and minus. See that. If for all x greater than 0, for all positive value of x, f of x will be what? 1. When x equals to 0, f of x will be what? 0. When for all negative value, the value will be what? Minus 1. So range of f is what? 1, 0 and minus. Okay? And next one is greatest integer function. And greatest integer function is what? It is also a real valued function. It is also a real valued function, and it is defined as f of x equals to greatest integer x for all x belongs to x. It is read as greatest integer x. Okay, and it is defined in this way. Okay, so and see that this one f of x equals to greatest integer x. Suppose it is what? Suppose minus 1, for minus 1 less than equals to x less than 0. Okay, value will be find like as integer plus fractional value. Integer plus fractional value, and it will be what? It will be the integral value. Suppose if we want to find, suppose f of x equals to, if we write x equals to 2.7, 2.7. So 2.7 can be write as 2 plus 0.7, 2 plus 0.7. So here greatest, if we define f is the greatest integer function, so their functional value will be what? 2 in that case. Okay, suppose if we write it is minus 2.7, minus 2.7, so it will be what? Minus 2.7, it will be what? Minus 3 plus 0.3, plus 0.3, then it will give what? Minus 2.7, minus 2.7. So the value will be what? Integral, greatest integral value will be what? Minus 3. Okay, integer plus fraction. Okay, suppose it is a integer, suppose f of minus 1, f of minus 1, then functional value will be what? Minus 1. Okay, this is the way to find the functional value of greatest integer function. Okay, greatest integer, for greatest integer function, functional value will be obtained using this formula. Remember that integer plus fractional value. Okay, suppose if we consider it is 2.5, the x equals to 2.5, it will be what? 2 plus 0.5. So their functional value will be, we consider only the integral value. So it will be what? 2. Okay, so for greatest integer function, domain is R and range is integer. Range is integer. Okay, remember this one. For greatest integer function, domain is always R, but the range is what? Range is the integer. Okay. Next, tell me about the algebra of real function. Suppose x and z are two real valued function, then f plus z is also a function which can be defined from x to r, because f is a function from x to r, z is also a function from x to r. So f plus z, addition of these two function can be defined from x to r, and this is obtain look like as this one. F plus z x is same as f of x plus g of x. Okay, suppose we consider we are given two function f and g which can be defined from x to r. then we can define another function by adding that two functions. Suppose we consider f plus z. Consider another function, addition of the two function, it is f plus z, so it will be defined from x to r. Okay, and it is write as f plus z bracket of x. It is same as f of x plus z of x. Similarly, we can define subtraction of two real valued functions. Okay, suppose we are given f and z two function. From these two function, we can define another function f minus z from x to r. This is defined as f minus z of x equals to f of x minus z of x. It is same as. Okay, and similarly multiplication by a scalar alpha f of x. Suppose f is a function from x to r and alpha is any scalar, any constant from r, then we can define another function alpha f from x to r. It is defined as alpha f x equals to what? Alpha f of x. Okay. And similarly, we can define multiplication of two real valued functions. Suppose we are given f and z are two functions, then we can define product of these two functions f into z from x to r. This is obtained as f c x equals to f of x into 0. Okay, and similarly, we can define quotient of two functions. Here we consider f and z are two real valued function, then we can define a function f by z. F by z is a function from x to r. Here it is defined as f of z divided by g of x. But here condition is what? G of x does not equals to 0. Okay. G of x does not equals to 0. And there is a note, see that the domain of sum of function f plus the difference of function f minus z and product of f of z is what? The intersection d f of df, that is domain of f intersection domain of z. Okay, and this is very important. See that f and z are two functions, and we can define another function by adding, by subtracting, by producting two functions. And here domain of that function is what? X belongs to d f intersection dz. Okay, here df is what? Domain of the first function, and dz is what? Domain of the second function. Okay. So for today, I will stop. In the next class, I will discuss some problems. Okay. So for today, I will stop. Any doubt?
No.
Have you any doubt?
No, ma'am. No, ma'am.
Okay then. And try to remember the definition. Okay, and CQ question will be comes from this type of definition. Okay, so try to remember the definition of the function and domain and range. Okay, try to remember that topic because MCQ for 1 mark. Okay, one marks. This type of question will be comes from that topic. Okay, so thank you.
Thank you, ma'am.
Thank you, ma'am.